Hello friends, today we are going to start a lecture series in paper 5th, that is Demography of Climate Adaptation of Bachelor of Population Studies. We will start this series by understanding two important and dynamic concepts, that is population dynamics and climate change adaptation. Both these concepts have become the subject of hot debate among the new generation of demographers, environmentalists, and population experts. Human population trends are centrally important to environmental science because they help to determine the environmental impact of human activities. Rising populations put increasing demands on natural resources such as land, water, and energy supplies. As human communities use more resources, they generate contaminants such as air and water pollution and greenhouse gas emissions, along with increasing quantities of waste. The linkage between population dynamics and climate change adaptation is to be investigated in the light of some specific key elements. These elements include why and how population and climate change interact, the specificity of impacts in urban settings, vulnerabilities for different populations such as children, women, the elderly, and the poor, and programmatic interventions including research, policies, programs, and advocacy. Research studies conducted in the last few years shows that demographic change is closely associated with greenhouse gas emissions, and that population dynamics will play a key role in attempts to mitigate and adapt to the effects of changes in the climate system in the future. There is an urgent need to create a balanced approach towards resolving the issues related to population dynamics and climate change adaptation. Well, a better exploration of both these concepts will help us in understanding the subsequent topics comprehensively. So, let us explore and understand these concepts one by one. First is population dynamics. A population is a group of individuals living together in a given area at a given time. Changes in populations are termed population dynamics. In other words, population dynamics is the branch of life sciences that studies short-term and long-term changes in the size and age composition of populations and the biological and environmental processes influencing those changes. Population dynamics deals with the way populations are affected by birth and death rates and by immigration and emigration, and studies topics such as aging populations or population decline. Every birth and death is a part of human population dynamics. Each time a person moves from one location to another, the spatial arrangement of the population is changed, and this too is an element of population dynamics. While humans are unique in many ways as a species, they are subject to many of the same limiting forces and unexpected events of all populations of organisms. Now let us talk about historical background of population dynamics. Population dynamics is the main branch of mathematical biology. A Malthusian growth model is widely regarded as the first principle of population dynamics. As the name suggests, this model is named after the great demographer Thomas Robert Malthus, who wrote an essay on the principle of population in 1798, one of the earliest and most influential books on population. This model is often referred to as the exponential law or Malthusian law. According to this law, human population grows geometrically, that is exponentially, while the food supply grows arithmetically, that is linearly. Malthus observed that the growth of the human population is fundamentally different from the growth of the food supply to feed that population. Here n is population density and t is time. This is the simplest model of population growth and assumes that the per capita growth rate, that the difference between per capita birth and death rates, is a constant r, often referred to as the intrinsic, that is per capita growth rate. The solution of the differential equation is shown on the screen now, where n0 is the population density at time 0. If r is greater than 0, the population will grow to infinity, whereas if r is less than 0, it will decline towards 0. Benjamin Gompertz and P.F. Wernhurst were the other two great demographers of the 19th century who refined and adjusted the Malthusian demographic model. Now, let us move to the next important point, that is elements of population dynamics. Population density, population growth, and population structure are the three basic elements of population dynamics. Let us talk about population density first. Population density is the measure of the intensity of land use, expressed as number of people per square kilometer or square mile. Population density is often reported and commonly compared statistic for places around the world. It is frequently applied to living organisms and particularly to humans. It is a key geographic term. Population density is generally used to refer to the number of people in a given area. This area can be any given space, although common areas such as provinces, countries, or states are generally used as data points. To calculate the population density for a given area, the number of people who are full-time residents are counted, and that number is divided against the square miles or kilometers of the area that is being measured. For example, if there is an area that is 50 square miles with 40,000 people living in it, the population density is 800 people per square mile. Density numbers generally do not include non-residents of an area unless they are living in the area for an extended time period. Next, we are going to talk about population growth. Population growth is the increase in the number of members of a population over a given time. Now, have a look at the list of the most populous countries of the world. As you can see on your screen, at present, China is the most populous country. Population growth rate. Population growth rate is defined as how quickly the members of a group increase in number over a set period of time. Such terminology is often used by social and biological scientists to discuss how fast a population of people, for instance, grows over time in a particular area. The rate of population growth is determined by a simple formula. The population size at the beginning of the time period is subtracted from the population size at the end. That number is then divided by the population size at the beginning to yield a fractional answer, which is converted to a percentage. Now we move to population structure. Population structure refers to the composition and makeup of people of different gender and ages within a given area. The population structure is commonly described using a population pyramid. Population pyramids are a useful tool for understanding the structure and composition of populations because they graphically portray many aspects of a population, such as sex ratios and age structure. A population pyramid is defined as a graphical illustration that shows the distribution of various age groups in a human population. So the word pyramid is used because it normally forms the shape. It typically consists of two back-to-back bar graphs with the population plotted on the x-axis and age on the y-axis, one showing the number of males and one showing females in a particular population in 5-year age groups. Now have a look at the population pyramid of India. Well, dear friends, now we move to the second important concept of today's lecture, that is climate change adaptation. Before we discuss the concept of climate change adaptation, let us know what is climate change. Climate change is a long-term change in the Earth's climate, especially a change due to an increase in the average atmospheric temperature. It is a change in the statistical distribution of weather patterns over periods of time that range from decades to millions of years. Climate change may be limited to a specific region or may occur across the whole Earth. Now, what do we mean by climate change adaptation? Climate change adaptation can be referred to efforts made by society or ecosystems to prepare for or adjust to future climate change. The nature of these adjustments can be protective, that is, guarding against negative impacts of climate change, or opportunistic, that is, taking advantage of any beneficial effects of climate change. Well, adaptation to changes in climate is nothing new. Throughout history, human societies have repeatedly demonstrated a strong capacity for adapting to different climates and environmental changes. Whether by migration to new areas, changing the crops we cultivate, or building different types of shelter. However, the current rate of global climate change is unusually high compared to past changes that society has experienced. In an increasingly interdependent world, negative effects of climate change on one population or economic sector can have repercussions around the world. Now it's time to talk about climate change adaptation efforts. A wide variety of steps can be taken by an individual, community, organization, or government to prepare for or respond to climate change impacts. Some of the examples are as follows. Agriculture and food supply. Breed crop varieties that are more tolerant of heat, drought, and waterlogging from heavy rainfall or flooding. Protect livestock from higher summer temperatures by providing more shade and improving airflow in barns. promote shore protection techniques and open space preserves that allow beaches and coastal wetlands to gradually move inland as the sea level rises. Identify and improve evacuation routes and evacuation plans for low-lying areas to prepare for increased storm surge and flooding. Ecosystems. Protect and increase migration corridors to allow species to migrate as the climate changes. Promote land and wildlife management practices that enhance ecosystem resilience. Energy. Increase energy efficiency to help offset increases in energy consumption. Harden energy production facilitates to withstand increased flood, wind, lighting, and other storm-related stresses. Human health. Implement early warning systems and emergency response plans to prepare for changes in the frequency, duration, and intensity of extreme weather events. Plant trees and expand green spaces in urban settings to moderate heat increases. Water resources. Improve water use efficiency and build additional water storage capacity. Protect and restore stream and river banks to ensure good water quality and safeguard water quantity. Now we come to the conclusion of today's lecture. Climate change is undoubtedly one of the biggest global health threats of the 21st century. The inevitable population growth is making it worse. While the principal cause of climate change is high consumption in the developed countries, its impact will be greatest on people in the developing world. Rapid population growth endangers human development, provision of basic services, and poverty eradication, and weakens the capacity of poor communities to adapt to climate change. Significant mass migration is likely to occur in response to climate change and should be regarded as a legitimate response to the effects of climate change. Linking population dynamics with climate change is a sensitive issue, but family planning programs that respect and protect human rights can bring a remarkable range of benefits. At the same time, understanding demographic trends, including fertility, population growth, urbanization, migration from environmentally depleted areas, and growing population density in marginal and vulnerable areas is also crucial for the world to adapt to and cope with the adverse impacts of current and projected climate change. Well, population dynamics has to be integrated systematically into climate change science. With this, we come to the end of today's lecture. I hope you must have enjoyed it. In the next episode, I shall talk about population and climate change, and I shall also throw light on the impacts of climate change. Till then, goodbye. Thank you very much.